Today we'll be writing Lewis structures. To write Lewis structures, we can follow these 3 steps. We will determine the element and the number of atoms in each molecule first. For step 1, we're going to write the electron dot notations for each atom in the molecule. And then determine the total number of valence for the entire molecule. So for SiBr4, Si on the periodic table is in group 14, just underneath carbon. This is silicone. So we have 1 silicone, there's no number that comes after it. Br is a halogen, it is in group 17. There are 4 bromine in this molecule. So for silicone, we are going to look at group 14. Since it's in group 14, we use that group number to tell us how many valence. So silicone will have 4 valence. Bromine is in group 17, so 7 valence. So we're going to draw out Si and Br, and we're going to put the 4 and 7th valence electrons around the outside. So 4 around silicone and 7 around bromine. When calculating the total number of valence electrons, you do however many are in the molecule times their number of valence. So for silicone, there is 1 in this molecule. That 1 silicone has 4 valence, so silicone is going to contribute 4 valence electrons. Bromine, there are 4 bromine in this molecule, and each bromine has 7 valence, making a total of 28 contributed by bromine. When you add them together, the total overall is 32 valence electrons. And you'll use this from step 1 to help you in step 3 to double check your number of electrons. Step 2, we need to identify the central atom, and to do so, it's going to be whichever one makes the most amount of bonds. So in this case, we have from the Honk rule, so H, hydrogen and halogens make 1 bond, O, oxygen and sulfur make 2, N, nitrogen and phosphorus have 3 bonds, and C, silicone and carbon make 4. So in this case where we have silicone and bromine, the silicone is going to make 4 bonds, bromine is going to make 1. So if this makes the most amount of bonds, it is going to be our central atom. So we have 1 silicone and 4 bromine. We're going to put the 4 bromine around the outside. And now we're going to give these shared electrons here in our skeleton structure. So silicone's going to share 4, so all of their valence, whereas bromine is just going to share 1. So for each of the bromine, we're going to go around and give them 1 of their valence to share, and silicone, we're going to give 4. All of these here will be shared between the different atoms. So we have 1, 2, 3, 4 shared pairs or bonds. These are all single bonds. And 2 electrons are in each of these bonds. Step 3, we're going to go and add any lone pairs that are left. And then we're going to double check our count. So we have our bonds, our 4. That gives silicone 2, 4, 6, 8. So silicone's happy. Bromine has 1, 2, 3 lone pairs. So over here, we're going to have to do 1, 2, 3 lone pairs. And each lone pair is 2 electrons. So there are 6 unshared electrons for bromine. So we have 2, 4, 6, 8 shared here in the middle, 10, 12, 14, 16, 18, 20. We gotta get up to 32. 22, 24, 26, 28, 30, 32. So these all have 32, the total for SiBr4. And each of the atoms has access to 8 valence electrons. So we are good to go for SiBr4. Our next one, CH3Cl, has 3 different atoms in it. We have carbon, hydrogen, and chlorine. We know that because every capital letter is the start of a new atom. So Cl on the periodic table, capital lowercase, is going to be chlorine. Carbon is in group 14, hydrogen group 1, and chlorine group 17. So hydrogen group 1 has 1 valence, carbon group 4 has 4, and chlorine group 17 has 7. So total valence here, there are 3 hydrogen contributing 3, 4 valence from the 1 carbon, and there's 1 chlorine giving 7 valence. So there's a total of 14 in CH3Cl. So for this, we're going to have our carbon, hydrogen, and chlorine. For our valence, we have 4 for carbon, 1 for hydrogen, and 7 for our chlorine halogen. If carbon is present, carbon is the central atom. We're also going to look at the honk rule one more time and determine the central atom as to which has the most amount of bonds. So carbon, having 4 to share, carbon on the honk rule likes to bond 4 times. Hydrogen and halogens bond once. Chlorine is a halogen, so it will bond once. And hydrogen is hydrogen, and it also bonds 1 time. So therefore, chlorine is our not our central, hydrogen is not our central, and carbon is our central atom. So we have carbon, hydrogen, we have 3 hydrogens, and 1 chlorine. Each hydrogen is going to share 1 valence electron. The chlorine has 3 pairs and is just going to share 1 as well for its 1 bond. And then carbon is going to share 4 valence electrons, 1 with each of the surrounding atoms. This makes for 1 bond, 2, 3, and 4 single bonds for carbon, and 1 bond for each of the hydrogens and halogens present. Now we're going to go and add our lone pairs, keeping carbon in the middle. So we have 3 hydrogens, our chlorine, and our carbon. We have 1, 2, 3, 4 bonds already, and chlorine has 3 lone pairs that we have to add on the outside. So we have 1 lone pair, 2, and 3. So our final should have 14 valence. We have 2, 4, 6, 8, since each line represents 2. So 8, 10, 12, 14. So we are good to go on CH3Cl. Lastly, we're going to do water. So we have 2 hydrogen and 1 oxygen here. So hydrogen is in group number 1. So it has 1 valence electron. So since there are 2, that's going to contribute 2 to H2O. Oxygen is in group 6 on the periodic table, or group 16. So there is 1 oxygen So we're going to put 1 times 6 valence electrons. That's going to give us a total of 6 provided by oxygen. And 2 plus 6, our final total for H2O, there are going to be 8 valence electrons. So we're going to draw our hydrogen and our oxygen. Remembering that there are going to be 2 that we have to double check. We have 2 hydrogen and 1 oxygen here. So hydrogen has 1 valence electron. Oxygen has 6. So we have 1, 2, 3, 4, 5, and 6. Based on the honk rule, hydrogen has 1, oxygen 2 bonds, 3 for nitrogen, and 4 for carbon. So hydrogen has 1, oxygen has 2. We're going to look for our central atom as the one that has the most amount of bonds. So we're going to have oxygen is going to have 2 bonds. We're going to put oxygen in the center. There are 2 hydrogens, so we're going to draw our 2 hydrogen. Hydrogen is each going to give 1 of its valence, since it only has 1. Oxygen is going to share 2 of its valence, and it's going to have remaining lone pairs after, so it's going to share 2. We are going to connect our shared pairs now. So this is shared between hydrogen and oxygen. They have 1 shared pair. And between the other oxygen and hydrogen, there is a second shared pair. So in our final drawing, we have oxygen, our 2 hydrogens still. Hydrogen does not have any lone pairs, but oxygen does. It has 2 bonds and 2 lone pairs. So we have our single bond here. For hydrogen, they each have 1. Oxygen has its 2 bonds, 2 single bonds. And then we have 2 lone pairs. So 1 and 2. And this is our final for water. We have 2, 4, 6, 8 electrons total, so we are good. 2 for each hydrogen and 8 for the oxygen. Our CF4 will look identical to the SiBr4. And for the Ni3, the nitrogen and iodine, we will have 3 single bonds from the nitrogen from the honk rule. So H, O, N, and C. The iodines will have 1 bond as halogens. The nitrogen will have 3 bonds because it goes 1, 2, 3, and 4 based on the honk rule. That's the number of bonds. Hydrogen and halogens will always have 1 bond, so they can only have a single bond here. Oxygen will always have 2. They can be single or double. And just one more look at the honk rule. So here, hydrogens and the halogens having the single. Halogens will have lone pairs, but hydrogen does not. Oxygen will have 2 bonds, oxygen and sulfur. They're both in group 16. So oxygen can have 2 singles or a double, as long as it has 2 bonds. Nitrogen with 3, whether it is 3 single, triple, or a double and single, it has 3 bonds. And carbon will have 4 bonds. And it has the most possibilities to get those 4 bonds.